Hello everybody, the video of today will be about steel concrete composite deck floors, and we are going to understand these floors by drawing a structural plan and adding two sections of the floor today. The first thing that I will do is I'm going to write here steel concrete composite deck, and I will write down the components of it. The first component of steel concrete composite deck type of floors is main beams. And the second component of them are secondary beams. Third component is the steel trapezoidal sheet. Fourth component is the shearstats. Fifth component is the reinforcement bars. Sixth component is the concrete. And the final component, which is going to be used for preventing the tapping concrete to fall down by flowing out of our floor, which will be called as L profiles. The idea is very simple. What is a main beam firstly? A main beam is a steel I-shaped section. These steel I-shaped sections, they are structural steel, which means that there will be some flash thickness in them around a centimeter. Okay. And what about the second? And you know from the previous week that in steel structured building, the height of the beam will be the height of the beam, let's call it as B, is equal to H divided by 20, or we call it as length as well. Okay, L is the span. We need to divide span into 20, and that will give us the beam height. That will give us the beam height. Okay, and this is what we use for main beams. The secondary beams, okay, doesn't necessarily be as high as, no, I wrote high, we need to as high as, erase that E letter there, as high as the main beam, because you know that the height or the size of a beam is related with two things. The first thing is the span that they pass, and the second thing is the load that they are bearing to. And as main beams are going to bear against more loads, they need to be slightly larger than the secondary beams. And what is a secondary beam? It is usually, again, a steel I section, but the height of it can be slightly smaller. How much? A couple of centimeters. That's what an architect needs to know, a couple of centimeters. Okay, which means that in the course or in our building has a shape like this. Okay, and it is around 5.5 to 5.5 years. Okay, and this size is 4, maybe 5.5, and we have got another 3. You can check these sizes from the sheets that I've given to you. I'm not sure about these dimensions, but what I'm sure is the maximum span of this building is around 5.5 meters. So in order to calculate the height of the beam, we need to divide 5.5 meters or 550 centimeters to 20. So beam height need to be something around 27.5, and that is for main beam. For second beams, okay, we can choose it to be something around 25 centimeters. Okay, once we know that these, we need to go back to the profile tables that I have shared with you, and you need to choose an appropriate real profile that we have. Okay, and there is an important rule. That rule is related with the steel trapezoidal sheets, so I will write it here. Okay, steel trapezoidal sheets may not pass more than 2.5 meters of a span. More than 2.5 meters of span. Which tells us that the maximum distance between, or the maximum span between two secondary beams, or the maximum span between a main and a secondary beam cannot exceed 2.5 meters. And what is a steel trapezoidal sheet? It is a steel sheet with a thickness of around a millimeter formed into this shape. And the name of this unique shape is called as trapezoidal shape. And by the trapezoidal shape, it gains a span passing and load bearing capacity. Okay, and we need to have shear stats. What's the function of shear stats? These are the members that tie, connect, combine, integrate, that tie main and secondary beams with steel trapezoidal sheet and the topping concrete. What is the shape of them? They are steel members like this shape. Okay, they have a special welding gun, and what do? We have a beam passing from here, let's assume. Okay, a beam passing like that, and over that beam we have a steel trapezoidal sheet going like this. Okay, we need to place it there. Okay, and it's going to, with special gun, melt down this steel beam to the steel trapezoidal sheet, and when we cast concrete, it's going to stay inside and prevent the concrete from sliding to sides. And what are rebars used for? This hatched part that I draw here is the reinforced concrete slab of the composite deck type of floors. Okay, it is a reinforced concrete slab which is supported with a steel trapezoidal sheet beneath, and that steel trapezoidal sheet is also going to act as a formwork for our reinforced concrete slab. And what do we need to do? We need to have a steel reinforcement bar mesh. Okay, and where will we put it? We are going to put it here. I want to erase this shear stat from there. Okay, so now this is our slab, this is our bar, and we are going to place the reinforcement bars here, which is going to make this concrete become a hole. Okay, and we pour concrete on top of them. And the final thing that we need to do, we need to have is, we don't want the concrete to flow down. That's why on top of our beams we place there a steel L profile. Okay, now let's show how this seems in a structural plan. Let's faintly draw here our building's borders. The borders of our building is something like this, I guess. Okay, and what will we do? We are going to place our H profiles here. Okay, to our H profiles, what will we do? We are going to tie our I-shaped profiles, or in other words, our beams. I'm going to erase the borders of my building in order to make you focus on the structural members only. Okay, and now we are going to tie these to each other with our steel secondary beams. Do I forget any of one of them? No, I don't. I need to tie each column to each other with a main beam. Okay, and here is the last one, like that. Okay, so let's name these. This is steel H profile, H section, and it is a steel column. As always, let's repeat this written information a couple of times. This is also a steel column, which is a, in parentheses I will write this time, steel H section. Okay, and let me put it in parentheses as well. What about this thing that we have here? That's a steel main beam, which is a steel I section. Okay. And what about this thing that we have there? That's also a steel main beam, okay, which is a steel I section. Okay, now the approximate dimensions of this building, it is 5.5 here. Okay, and it is let's say 4 meters here. Please check all these dimensions from the papers that I'm giving to you. And this is also 5.5 meters, and this is another 3 meters there. Okay, again, please don't forget to check the real sizes in the sheets that I have given to you. Okay, it doesn't matter, we are talking about the idea. So this is 5.5 by 5.5. Okay, what we need to do, we need to put the secondary beams parallel to long main beam direction. Okay, in other words, it needs to transfer loads to the secondary beams. As we have got a square shaped place here, the placement of the placement of the secondary beams is not very important. As it is square, they can be placed however we like, but don't forget that divide 5.5 into 2.5, you will have more than 2, which means that, let's put it here, doesn't matter, one secondary beam and another secondary beam here. We need to put 2 of them, because if I put just one of them, I am going to have more than 2.5 meters of a span. Okay, and when I come to here, let's assume that it is 4 to 5.5. I need to place my secondary beam this time on a different direction. And when I come to here, again, I need to put my secondary beam on this direction. Okay? And over my secondary beams, what am I going to do? I am going to place my steel trapezoidal sheets, okay, in order to expose my beams underneath. I'm going to draw them partially, okay, and I'm going to draw it here, and I will draw it like that there. Okay, firstly, steel trapezoidal sheet, okay, needs to be cut for being able to place them in the right places. Okay, at the corner points, I'm cutting it. At the sides, it continue until the end, and it's going to have fold lines like this here. This is my steel trapezoidal sheet, and on the other direction again I will cut it to certain sizes in the corner points. Okay, and I will do that same here as well. When I come to here, again I cut the steel trapezoidal sheet. It continues until the borders, and I am going to like that. I cover it entirely with steel trapezoidal sheet, and when we come to here, we are going to cover it entirely with steel trapezoidal sheet as well, like that. Okay, and now it is time to place the shear stats. Okay, let's place the shear stats. Here are them. Okay, pink is representing the shear stat. Don't forget that the shear stats will not be welded to to the steel trapezoidal sheet. They will be welded onto the steel beams that we have. Okay, so we need to weld them to the steel beams. We need to put them in these orders then. Okay, all purple lines. Of course, they need to continue until the end, but in order to easily show them, I don't draw all parts of it. Okay, let's write down some more names. What is the name of this thing? That's a steel secondary beam, and it is a steel I section. What about this one? That's also a steel secondary beam. Okay, and what do we have right here? We have got steel trapezoidal sheet. What do we have here? We have got steel trapezoidal sheet again here. Okay, and then the borders of my building, in order to prevent the concrete to flow down, I need to surround my steel trapezoidal sheets entirely with air profiles. Okay, they will prevent the concrete to flow down. Okay, and now I am ready to cast my concrete. Okay, let's cast it. Okay, so let's draw it this way. The orange hatched parts are representing my concrete. What concrete? Tapping concrete. Okay, inside my tapping concrete, what do I have? I've got reinforcement bars. Okay, with brown, I am trying to represent the reinforcement bars there. Okay, like that. Coming out. So out of the concrete. This is all about the steel trapezoidal sheet, concrete, all together, steel concrete composite deck floors. What we need to do, as always, we need to put an elevation like this and like that. Okay, and also what do we have? We have got, let's raise here also, we have got the axis. Remember the axis? Okay, A, B and C axis here, and 1, 2 and 3 axis there, with a dimension of 5.5 and 4 maybe, and we have got here again 5.5 and 3. Okay, and this is going to be the first drawing on the page. What is the name of the drawing? That's the first floor structural plan with a scale of 1 to 50. Okay, and what will we do now? We are going to draw a section. It is the second drawing on the page. Okay, and this is, let's assume, to be the 7th page, and we draw it on the same page as well. Okay, and it is a section. Okay, again scale 1 to 50 maybe. The first thing that we need to draw is the columns. And the second thing that I will draw is going to be my main beams in section. Here are there, here they are. Okay, and then I'm going to draw my main beams on elevation. Main beams are tied to columns, don't forget. Okay, that's why I'm not extending these lines until my beams. Okay, and then I also have here behind a secondary beam which is parallel to this direction, and here is that secondary beam. When I look at here, the section plane cuts a secondary beam in section. So here is my secondary beam. Okay. On top of this part, I have my steel trapezoidal sheet being cut by the section plane perpendicularly like this. Whereas when I come to here, it will be placed parallel like this. Okay, and in order to prevent concrete to flow down, maybe I can add another L profile there. Let's color match them. Okay, an L profile here, maybe another L profile there, one more L profile here. Okay, and then we are going to place our shear stats. So here are the shear stats. Okay, and before casting concrete, we are going to place our reinforcement bars here, and then this is going to be the concrete that we have. Concrete is going to fill all these spaces, okay, and the shear studs will be left inside the concrete. Okay, whereas here I will draw it entirely concrete like that. Okay, and don't forget that steel trapezoidal sheet is right there. Okay, but we don't see it because it has been cut parallel to their fault lines with the section plane. Okay, and now let's write some names. What's the name of this thing here? That's a steel main beam. What about this thing behind, below it? That's a steel column. Don't forget that we use a dashed and dotted line in order to represent that something continuous in architecture. Okay, let's draw it as an intermediate floor at this stage. Okay, that's why I'm going to draw it with these cut lines as well. Okay, and this thing that we have here, it's a steel secondary beam. I have space and I will write it above that space. That's a steel main beam. You see it, it's on elevation. Okay, and we have got our steel trapezoidal sheet there. I supported my drawing with written information. Now I'm going to turn it upside down like that. Okay, pull it slightly down. Okay, and I will draw another section passing from here and there. It will be the third drawing on this page. Let's assume I have told that it's the 7th page. Okay, and here is how it will be seen. Again, we are going to have a column here, another column there, one more column here, and we are going to have one main beam here, another main beam there, one more main beam here, and we are going to tie those columns to each other with main beams on elevation. Okay, and this time here the section plane cuts the secondary beam in section, and the secondary beam will be here in this elevation. On top, I am going to have my L profile here, another L profile there, one more L profile here. Okay, and I will have my steel trapezoidal sheet there, and my steel trapezoidal sheet in section there, like that. Again, everywhere I have got my shear stats, lots of shear stats I have. Okay, and I have shear stats here as well in elevation, and I have got my steel reinforcement bars like that, and I use concrete here and there entirely. Okay, and again this dashed and dotted line, dashed and dotted line. Okay, and this is a steel column, that's a steel main beam. This is steel main beam on elevation, and this is my steel secondary beam. Okay, and this is also my steel secondary beam, and I have got concrete here. What concrete? Topping concrete. Okay, that's all. Okay, let's turn it upside down again like that. So you need to draw this drawing until this Monday. Thank you for watching my video, and see you on Monday.